Yeah, I still have the microphone muted, so you probably can't hear me, but we'll go through this in about a minute. Okay, great. Well, let's go ahead and go over these together. Um, Hopefully, you've been getting a lot of practice with these and kind of working your way. Once you see one problem that's done in a certain way, you can kind of catch that. Some of the more trickier ones, like maybe number two, uh, of what you're going to need to do in order to solve that. I appreciate all of you for your patience. I apologize for being absent. I normally can move stuff, simply just move it to Zoom and work through being whatever it is that I'm dealing with. But with the level of fever that I had on Monday, it just wasn't possible for me to think straight and actually be much help to anyone. So, but luckily our topics kind of bump up together. These are just spread over the same section, just maybe some more difficult ones in the second half of the assignment today. And hopefully we can work through these together and you can feel pretty good about the system that we have. One thing to remember with all of these, when we're going between thinking between 0 and 2 pi, that's one revolution, right? So if I have a positive solution that I'm looking for, uh, there's going to be two of them, right? Because there's two places where cosine is positive, so two angles between 0 and 2 pi where we would have solutions with sine and cosine. And then it's plus 360 or plus 2 pi n, right? That's how we write the infinite set. And between 0 and 2 pi, there should be two solutions as well most of the time. When we square something, which we may see more of that in today's assignments, uh, then we need to check our solutions and make sure that they fit. Whenever we square an equation on both sides, we always pick up extra solutions. For example, just going back to a regular equation, you can take, an equation is any statement of equality, right? X equal to 2, that's a statement of equality. X is equal to 2. So this equation has one solution, 2. But when you square both sides, and I say x squared is equal to 2 squared, well, now we have x squared is equal to 4. And there's actually two solutions. In fact, generally, there's as many solutions to an equation as your highest power. Now, in other complex situations, some of those are imaginary solutions, but they're still considered solutions if we're including the imaginary set of solutions. Like here, the actual number of solutions is positive and negative 2. Negative 2 squared is 4, and positive 2 squared is 4. That's why whenever we take the square root of both sides, we have to take the positive and negative. Um, and that's because we're reducing the power there, right? So we took it from a second squared equation of the second degree to a first degree. Um, but the original equation was a second degree. Here in this case, our original equation was x equal to 2 as a first degree equation to the first power, right? And so negative 2 is not equal to 2. And so negative 2 would be an extraneous solution that we picked up when we squared both sides of the equation. That makes sense. Sorry, you may hear my dog. Uh, hopefully, he won't do that very often. It's usually just when the mailman is in the neighborhood. Okay, and then he goes outside. Um, so let's take a look at what we have here. When we have the sign parentheses of something like this, the way we can kind of get rid of our sign is to take the arc sine of both sides, right? That's kind of the idea. So we're taking the arc sine of the sine of x plus pi over 4. And that kind of just gets rid of the sign. And then we're taking the arc sine of 1/2. And the arc sine of 1/2 gives us an angle that we know where the sine is equal to pi over 2. What is that angle in radians? You guys can type that into your chat box. What is the arc sine of 1/2? That is correct. It's the y value when the y value when we're at 30 degrees or pi over 6. So now what I have is x plus pi over 4 is pi over 6. Now we also need to take into consideration the other thing. Whenever we take the arc sine, we're limited on the range, right? Because the function arc sine only gives us the positive values in the first quadrant. But there's another angle that also produces that, and that is the angle in the second quadrant. So what is the other angle that gives us pi over 6? I'm sorry, the other angle that gives us 1/2. That's in the second quadrant.
Pi over 6.
Pi over 6. Good. So we're going to want to do both of those. So we have this x plus pi over 4 also equals 5 pi over 6. Now, the book likes to give us formulas to work with, but I think it's most helpful and easier to do rather than use formulas. Basically, it says use, I should probably note when you come back in, if you get kicked out and you come back in, make sure that your microphone is muted. Sometimes it automatically will let it be not muted, and it's okay. I can mute you from my space here. At any rate, now we want to solve both of these. So we got to subtract pi over 4 from both sides. And that will solve this for x. So we need to get a common denominator here. So I'm going to make this, we're going to use 12 since 6 and 4 are both going to 12. So that would be 2 pi over 12. And then this would be subtracting 3 pi over 12. And this would be 10 pi over 12 minus 3 pi over 12. And so this gives me x equal to 2 pi minus 3 pi is negative pi over 12. And then over here, we get 7 pi over 12 to minus 3. So those are our finite solutions between 0 and 2 pi, negative pi over 12, and 7 pi over 12. But if we want to capture the solutions infinitely, because we can always add 360 to pi over 12 or negative pi over 12, for example. Negative pi over 12 is just 15 degrees, negative 15 degrees. But whenever we go around, if I add 360 to it, I'm in the same position. We would get the same solution. So my infinite set is negative pi over 12 plus 2 pi n and 7 pi over 12 plus 2 pi n. That 2 pi n is just saying for every 360 degree, for every rotation, those would be, we would get that solution of 1/2. Any questions on that? Yes. Yeah.
I didn't follow. How did you get 7 pi over 12?
10 pi minus 3 pi gives me 7 pi. Because I had to get a common denominator. So I multiplied the first one by 2 on top and bottom to get 10 pi over 12, and then multiplied the top and the bottom by 3 for the second ones.
But wouldn't there only be one angle for because since it's inverse sine and its restrictions is pi over 2 to negative pi over 2?
Correct. Yeah. When we're dealing with you're talking about the inverse sine, just gives us one.
Yeah,
So,
pi over 6.
mhm. Um,
Mhm.
that's true. But here we're talking about all of the angles, within the system. And negative pi over 12 actually is in the fourth quadrant, 7 pi over 12, that's in the second. But regardless, we have to find all of the solutions, and there is another angle, 5 pi over 6, which is in the second quadrant, which also gives us positive 1/2. So your calculator is programmed as a function. In other words, it's programmed to give you one solution, right? And for a function, for an input, you only want to have one output. But the reality is, whatever we plug in for X, we want to find all the solutions. So you got to come up with that other one that exists out there. And we know for sine is positive here and here, right? So you want to also include this other angle. Cosine is positive here and here. So if it was cosine we were dealing with, we'd need to find the angle in the first quadrant and the fourth quadrant. Notice that they're different angles. So the plus 2 pi n is not going to cover those. Does that answer your question? So the second
Yes.
here, I had to take a step back because if I just plug that into my calculator, for example, it's only going to give me the one in the first quadrant, the pi over 6. So I got to go, wait, but I know that with sine and cosine and pretty much every angle, there's two places where we would have a solution. And so you want to figure out what that second angle is going to be.
Professor.
Yep.
Uh, is that a right next to the pi over 6? Is that a why did you put a 2 pi over 12? And why did you put the 10 pi over 12 for these both?
Because we needed to subtract them, and they have to have a common denominator, right?
Yes, but I don't understand. Why are you getting the common denominator from what? Pi over 4?
Mm-hmm. Multiply the top and the bottom by 3,
Okay.
right? And then multiply
Um,
the top and the bottom here by 2 to get 12.
yes, but just but the x plus pi over 4,
Mm-hmm.
shouldn't you be doing the same for that one or no?
Well, I did once I interacted the two fractions over here on the left. In order to actually do the subtraction here, you've got to get a common denominator. How else would you subtract them? if I have to go 60, I mean, basically 30 degrees minus 45, we're going to get negative 15, right?
Yes.
But to to get that, which is what negative pi over 12 is, it's 15 degrees. So to interact those, you've got to have a common denominator.
Okay.
Yeah.
Just so the pi over 6 becomes 2 pi over 12, but why did you subtract 3 pi over 12?
Because we were subtracting, I'm interacting pi over 6 minus pi over 4, right? So I have to get them with the denominator the same. So I rewrote them right here. And so they have the same denominator.
Oh, okay.
Yeah.
Thank you.
Hmm. I mean, you could do it at the beginning. If I wanted to, I could say, well, this is 3 pi over 12 instead of pi over 4. You could do that at the beginning if you wanted to, so that you can see it at the beginning. That's perfectly acceptable as well. Isael, did you have another question? I put your hand down because I thought maybe, but I didn't know if you raised it a second.
No,
Okay.
no, I had a question. Yeah, so what I did was I solved for x, which was, yeah, I did the same as you did, 2 pi 12 minus 3 pi over 12,
Hmm.
which got me x equals negative pi over 12 plus 2 pi n.
Hmm.
But I also, because I did the book's way, which I try to solve for the other set, which would be x equals pi minus negative pi over 12, which would be x pi plus pi over 12 plus 2 pi n. And I got x equals 13 pi over 12 plus 2 pi n. Like I got the first part, negative pi over 12, but I didn't get the second corner right. I got 13 pi over 12.
13 pi over 12.
Yeah,
Can
because pi plus pi over 12,
you,
we have to get common denominators. So I multiply 12, both the numerator and denominator are pi because pi is over 1. So I did 12 pi over 12.
hmm
So I added that to pi over 12, which got me 13 pi over 12.
let's see. If I put in 7 pi over 12 and I add pi over 4, which would be 3 pi over 12. So I think what you're doing, you have to look at the original equation, plugging it back in. If I plug in 7 pi over 12 and I add pi over 4 to it, I'm adding 3 pi over 12, which makes it 10 pi over 12, which is 5 pi over 6. So that gets me to the 1/2. But if you have, what did you end up with?
13 pi over 12.
13 pi over 12. 13 pi over 12 plus 3 would be 14 pi over 12. In other words, if I'm plugging, I'm sorry, say what you got again. My brain still is
Yeah, I got x equals 13 pi over 12 plus
13
2
pi.
pi n. Yeah,
So if I plug that back in, right, for x, because these are my two solutions.
yeah.
Um, 13 pi over 12 plus 3 pi over 12 is 16 pi over 12, which reduces down to 8 pi over 6, which reduces down to so over 6, which reduces down to 4 pi over 3. That's something in the third quadrant, which wouldn't give me positive 1/2. It would give me negative. Uh, yeah, that would be not a correct solution. So I think the problem that you're doing is taking, let's see, you went back and you used the formula. This is why it's easier. Uh, you went pi minus theta, right? Plus,
Yeah, yeah, yeah.
yeah.
That's
So,
what I did.
yeah, which is how I got 5 pi over 6. Because it's the other angle that gives us that value, right? If you go pi minus pi over 6, pi over 6, this is 6
Oh, okay. Well,
6. That gives us 5,
uh-huh, uh-huh.
right? That's your other angle. And that's what you want to set that inside parentheses equal to. So
Okay, so
it may be that
yeah,
you're
I think I did.
thinking theta as the pi over 12. That's after we've subtracted pi over 4. So you want to see what that is doing. When I go pi minus the theta, we had, what do we have? We had basically this to start out with, right? We had 30 degrees. That's the thing.
Mhm.
So if I go pi minus 30 degrees or pi minus pi over 6, you see how it's giving you the other angle that formula is giving you the other angle in the second quadrant, which is 5 pi over 6. That's the other one you want to set it equal to. We set it equal to the one in the first quadrant, and we set it equal to the one in the first quadrant. That's the theta you want to use, not the pi over 12 that you end up with at the end. So let me
Okay,
just,
yeah, I see what I no, I see what I did wrong. I calculated it after subtracting pi over 4 to both sides,
yeah,
and then I did pi minus the pi
yeah,
over 12.
right.
So
So
yeah.
what you, and so that's why I say like that formula there is just saying also include the one in the second quadrant. They give a formula for it because that's nice to have a formula, but that's something you can figure out like without using the formula. You can go, well, what's the one in the
Yeah.
second that I would need? And that's probably a quicker way to go because you end up with two thetas, right? At the end, we end up with negative pi over
Mhm.
12. And then you're like, well, which theta are they referring to? Which angle are they referring to in that formula? Well, they're referring to the original angle. And that's because we have all this stuff in the parentheses here. So,
Another question. Yeah, since it's asking sets between 0 and 2 pi,
mhm.
wouldn't it just be 7 pi over 12? Because negative pi over 12 is outside the 0.
uh, say your question again.
You see how it's asking 0, asking sets between 0 and 2 pi?
Yeah. In other words, what
We got two.
in the first
Yeah,
rotation? Yeah.
uh-huh. But negative pi over 12 is outside 0. So wouldn't that,
Oh,
like, it would count for infinite,
no, you're right.
but it wouldn't count for finite?
No, you're right. It shouldn't be negative. You're right. We actually need to express this as, yeah, this should be actually, thank you, 23 pi over 12. Because 24 pi over 12 would be uh, two rotations, right? Two goes into 24 twice. So that 24 pi
Yeah,
over 12 would be 2 pi. So then we take one away from that. That gives us that reference angle of,
yeah,
thank you. Yes, that would be
yeah.
correct.
Uh, oh yeah, one more question. How do we know when to stop finding uh points or sets after you pass 2 pi?
How do we know
Because
when?
I keep getting yeah, I keep getting confused on that part when I'm doing the home when I was doing the homework.
Um, I think your question might come up with some of the ones from today's. Uh, but these are the only two angles, according to what we found here, right? That
Hmm.
are in the first rotation. This
Yeah,
one's
they are.
correctly, but yeah. Um, you can be confident that that's the only two. Um,
Yeah.
and then with the other ones, um, you can put. I don't think we have to change that negative because they don't in the infinite set. They don't say it has to be. Um, you can, in other words, you can use negative pi over 12 in the infinite set. It's the same
Yeah,
angle. It's
infinite set, yeah.
yeah. Um,
But when it's asking like 0 to 2 pi, I
mhm.
like me personally, I try to input that in the homework
Yeah,
and it said I got all the coordinates right, but that negative that negative coordinate should not be
yeah.
where
It's
should
not,
not be in that 0 to 2 pi. Yeah.
uh, and that's because it's outside of the finite set that they set
Yeah,
zero.
exactly. Yeah.
All right. Tell me what you guys got for number two. I just want to see how many of you got what you guys got for solutions. You can send it to me as a direct message. I'm gonna clear this off really quick, unless there's any more questions over anything I did there. Just want to get your screen. Yeah.
Just a quick like a quick just a quick question. How did you get a 23 pi over 12? The way you did it was you used
So,
the method x plus pi over 4 equals pi over 6 plus 2n pi,
so
correct? Or
yeah.
okay.
When I'm doing it, we're we're basically at negative uh, 15 degrees, I think is where it is. Right? That's what
Mhm.
negative 5 or 12 is. Sometimes it helps me to convert this into degrees, but think
Yeah.
about, um, well, you can just go, what would it be if I add 360 to it? So if I take negative pi over 12 and I re-expressed it by adding 2 pi to it, that'll give me, that's why we go plus 2 pi n.
Hmm.
This is if we want to get a denominator of 2, this would be 24 pi over 12. And 24 plus
Yeah.
negative 1, think of this as negative 1 pi. That's 23 pi over 12.
Hmm.
So I kind of just did that in my head, but I didn't write that out. Does
Okay.
that make sense?
Can I just yeah, let me write it quickly in my notebook.
Right. I'm going to go ahead and stop my share for a minute so I can go back with a clear screen. Okay, let's go ahead and do the second one. So if you tag me in the chat box, you guys have your chat boxes there, just tag my name. Let me make sure I have just send it to the one that says host. Send me what your solutions are there for the second one. So I could see what you got as your answer. And you don't have to actually, just send me the ones between 0 and 2 pi. You don't have to write out the infinite set. Just send me the two or more solutions that you got for your finite set. In the chat box. All right, now when we have something like this, notice that it's a cosine squared plus a sine to the first, and then minus 3 equals 0. This obviously looks like something where we would have an x squared uh, or 2x squared minus 3x minus 3 equals 0, like a polynomial equation, right? Where we would need to factor this because of the squared being there. The one problem also that we have here is that one of them is sine and the other is cosine. We're going to have trouble factoring that when we have differing trig functions like that. But because we have a cosine squared, we know that we can replace that with, we can relate that to sine because cosine squared plus sine squared is equal to 1. So if I want to replace the cosine squared, I can subtract sine squared to the other side. So we have cosine squared x is equal to 1 minus sine squared x, right? That's our trig identity, or our Pythagorean identity there. And so that's what the first thing I'm going to do here is swap out the cosine squared so that I'm just dealing with sine, so I can truly do something like this. We can't really do that with them differing. So I'm going to put in 1 minus sine squared x in place of cosine squared x. And then simplify it down. We need to distribute this to both parts. So now I have 2 minus sine squared x minus 3 sine x minus 3. And then combine any terms that we have that are like. I can combine the 2 and the minus 3. That leaves me with negative sine squared x minus 3 sine x. Negative 3 and positive 2 become minus 1, equaling 0. I do everything right there. I think so.
Professor,
Yeah.
uh, isn't it 2 minus 2 sine
2.
squared x?
Yep. Thank you.
Okay.
Thank you. That should distribute to both parts. I appreciate the corrections because, again, my brain is somewhat mush here a little bit. I'm making very obvious errors here. So now they're both sine. So now it really does fit what we have here, but of course it's different now. And we've got negative. We never like to have negative in the front. So I'm going to multiply both sides of this by -1 just to make that first one not negative. That makes it harder to factor. And so that -1 is going to change the sign of each one of these. So this would be sine squared x plus 3 sine x plus 1 equal to 0. 0 times -1 is still 0. So if it helps you to not have the sign in there when you factor it, you can picture it that way. Just put in 2x plus 3x plus 1 equals 0 and factor this 2x squared. With our double parenthesis, 2x and x. With plus and plus, we know that this is going to be plus and plus, 1 and 1, and this would give me 1x plus 2x is 3x. So here's the worked out factoring. Let's just put sine x back in there now. So I'm going to move this over to here. So we'll go 2 sine x plus 1 and x, or sine x plus 1. And this still works. Like if you did your inners and outers, I know it's sometimes hard to see, but sine x times 1 plus 2 sine x plus 1, or times 1 is 2 sine x, 1 sine x plus 2 sine x is 3 sine x, which is what I have in the middle there. And so this does multiply to give me what I've factored down. Now, the reason we have to factor like this, and this is equal to 0, is that if I have a product resulting in 0, then what I would plug in for x, what angle I would plug in for x that would give me 0 in the first times anything over here, maybe it's a 6, and we get 6 as a result. 0 times 6 is equal to 0. And anything I would get as 0 here times whatever I would get with that same angle here, maybe I get 4. 0 times 4 would give me a 0 as a result of multiplying. That's that special property of 0 that we have. And so it allows us to break this into two different statements that we can solve. One is where 2 sine x plus 1 gives me 0. And we figure out what would make that first parenthesis equal to 0. And the other is where the second parenthesis, sine x plus 1, would equal 0. And we find solutions for both of those. So for the first one, if I subtract 1 to both sides, I have 2 sine x equals -1. Divide by 2, I see sine x is equal to -1/2. Okay, and then we would find the x's that give me -1/2 for sine, or the angles that give me -1/2 for sine, which we found in the first instance, but not the second one. We know this using the arc sine would give us the negative between 0 and it would give us something in the fourth quadrant, negative pi/6. So that's one of my solutions, but also it's negative in the third quadrant. And so that would be 5 pi, or sorry, pi plus pi/6. So that would give me 7 pi/6, or 6 pi/6 plus one more pi/6, 7 pi/6. So those are two solutions that would make this first parenthesis equal to 0. And then whatever would come out here, it doesn't really matter. 0 times whatever we would get there would also come out to be 0. On the second half here, if we subtract 1 on both sides, I get sine x is equal to -1. And there's two solutions where we get, actually, there's just one solution where we get -1, and that's x equal to negative pi/2. So for my infinite set, I can put all these plus 2 pi n. So we have negative pi/6 plus 2 pi n. 2 pi n. 7 pi/6 plus 2 pi n. I keep on wanting to put it over n. And then negative pi/2 plus 2 pi n. All right, let's think about what those are between 0 and 2 pi. I see I got a hand raised. Go ahead and tell me your question there. How did I get 7?
Wouldn't it also, no, wouldn't it be also 11 pi/6 for 2 sine x plus 1 equals 0?
Yeah, you could say it that way. Just the arc sine, remember, only gives us
Oh, okay.
sine only gives us
Oh,
between pi/2 to pi/2. So that's why I said
oh,
negative.
you inversed it,
Yeah,
correct?
to undo
Okay.
this.
Okay.
Yeah, just didn't write that in.
All right. Yeah. Okay.
Yep,
Thank you.
no problem. Now, when we go to do the finite set, we need to figure out what all those would be, right? Like negative pi over 6 isn't between 0 and 2 pi. So we need to figure out what that would be, which would be 1 less than 12 pi over 6, which is 2 pi, right? 12 pi over 6 is 2 pi. And if I add negative pi over 6 to that, oops, pi over 6, we get 11 pi over 6. So that's one of my solutions here, 11 pi over 6. And then 7 pi over 6 is in there. That's in the third quadrant. So I wrote out basically the one in the fourth and the third, the two places where sign would be negative. And then we have this negative pi over 2. Well, that would just be 3 pi over 2. Add 2 pi, 4 pi over 2 to negative pi over 2. So 4 pi over 2, which is 2 pi, and then add negative pi over 2 to that. We get 3 pi over 2, which is 270 degrees. Yes.
Professor.
Yes.
So there's six finite sets.
There's three uh, finite set solutions.
But what about the 4 pi? Oh, my bad. Didn't see that. Okay. Thank
Yeah.
you.
No, I was just trying to give detail about how I got the 3 pi over 2. Yeah. Mm-hmm.
Okay. I think you said the question and not that out. I was gonna ask later, but how did you get 7 pi over 6?
7 pi over 6 would be 6 pi over 6 minus negative pi over 6. If you're thinking about the formula, right? Uh, so remember in the formula, you have to take um, x is going to be equal also to pi minus your theta. So pi minus your theta, which was negative uh, pi over 6, right? Yeah. The theta was negative pi over 6. This is
Uh,
minus negative becomes plus positive. So this is 6 pi over 6. But again, I'm picturing, okay, I have the one here that's 30 degrees. I also had this one, which was 30 degrees. These both give me the same negative 1/2, right?
okay.
So I'm thinking, all right, well, this is pi, which is 6 pi over 6. So what is that? It's one more pi over 6. But you can see with the minus negative, that becomes plus positive. So you end up adding it. So you get 7.
Okay.
Yeah.
All right. Thank you.
So it works in the formula, but I find the formula to be a little confusing. Um, just because it's easy to forget that, hey, I'm subtracting a negative, it needs to become plus positive. Think about if I have an angle in the fourth quadrant that's giving me negative 1/2, I also know in the third quadrant I get negative 1/2 with sine. So what is that angle? Well, it's 6 pi over 6 or pi plus another pi over 6. So the reference angle there is pi over 6 in both cases. All right, they're both pi over 6. If we look at what it's going back to the x-axis, they're both pi over 6. So they're both going to give us the same sine outcome. Does that make sense? I tend to picture it within the angles that are out. If they're positive, the angle would be up here. And I want to describe both those angles. If they're down here, I want to describe those two angles, the original angles. in this case, we didn't have something within X where we're gonna, at the very end, subtract pi over 4 or something like that. That's specific to here because they have that in parentheses before we've taken the sign of it. That's why we ended up with a couple of ones that don't have the same reference angle. In most other cases, you will. Okay. I bet there are probably some questions that came up in the homework and you're trying to go, this reminds me of some problem that I ran into. So let's go ahead and, if there's no other questions here about how I got those, let's go to questions from your homework. Did you guys end up with any questions from the first that you weren't able to get? I'm going to unshare this and go to my desktop. All right, you guys can see my desktop now. Let's go into my math lab. As far as I still have a few more tests to grade. So I'll be posting those, I'm hoping by tomorrow. It's taking me a lot longer. I hope to have those done a lot, but I ended up getting sick on last Thursday. So I'm a little backed up. But I definitely expect, I feel much better today. So I definitely expect by Monday we'll be back in class together. Let's see. So let's go to the part one first. Tell me any questions that you had from part one of the homework. You can post them in the chat box. This is from part one. Yeah, I will probably, because you guys have had to wait so long, I'll probably, no, it's definitely, I'll hand them back to you physically on Monday, but I hope to actually, since you guys have had to wait so long, I'm going to send them to you, your graded exams electronically so you can look at them uh, once I have those done. But it takes me a while to create all the electronic files to send them. But I don't want you guys to have to wait to see your results. So I'm probably going to send those to you electronically through Canvas once I have those done. It's a lot more work, but you guys have been waiting to see them, and I understand the frustration there. Just remember, if you're frustrated, I'm frustrated too, because I like to get them back to you as quickly as I can. I remember as a student, I hated waiting weeks to get tests back, and that seems to happen a lot. So I always like to get them back to you soon because I think the fresher it was in your mind, the more you can go back and evaluate those. Any questions from part one? Any questions from part one? Question number 8. Okay, let's go to number 8. Okay, find all the solutions of the equation secant x equal to -1. Okay, for secant x equaling -1, where does secant equal -1? Well, secant is in relation to sine, or I'm sorry, cosine. And so if we go cosine of x equals -1, yeah, cosine is equal to -1 at 180 degrees, which would be x equal to pi. But they're doing, I guess they're doing it in degrees, aren't they? So we're 180 degrees. Because the reciprocal of -1 is -1. So, right, and cosine and secant are reciprocal functions. So they're going to end up with -1 at the same place as cosine, or as cosine or sine, depending on which one you have. So, but that's going to be for every rotation. With sine and cosine, it's always for 180 degrees. And this is the only place where cosine will equal -1. It equals +1 at 0, um, and -1 at 180. It equals undefined at, well, secant would be undefined at where cosine is equal to 0. So you would have two places where it would be undefined, pi/2 and 3 pi/2. Okay, so I think the second one is our winner there. Let's see what the other ones are saying here. This would have to give us 2, but with this one, there's only one place where we get -1. So we're going to type that in, 180 degrees plus n times 360. That makes sense. That answer the question there? Any other ones? From the first section?
Uh, can we see the question, kind of like the last one, basically question 16?
My butt sucks.
The yeah, somebody's got their microphone on. Okay, this one's a little more difficult, isn't it? Okay, so let's first, and we only need to give the interval 0 to 2 pi. But if I subtract pi/3 and then divide by 2, we easily see that this is going to morph into the sine of x minus pi/3. Everybody equals negative square root of 3, because I have to subtract the root of 3 to the other side and then divide by 2, so -√3/2. Does everybody see how I got to this place? Okay. Yeah, no problem. You guys are probably in the same room. So let's figure out, and I'm just going to put u in here first. I'm going to say, let's make u equal to x minus pi/3. This is just a little sleight of hand here, to save this part for later and just find out where does sine of u equal -√3/2. This isn't a method you have to take, but I'm hoping it might help. So we can see that u would be equal to the two places. If we take the arc sine of both sides, this would give me the negative for sine, which would be negative. The one solution would be negative pi/6. Is that right? No, pi/3. That's our fourth quadrant angle, right? And then we have the other place where it would be negative, that we have to include as well, which would be in the third quadrant. So 3 pi/3 plus another pi/3, or pi plus a pi/3, would give us, right? So in other words, it's down here, it's -60, but the other place we know is here in the third quadrant where we would get something negative. So pi plus a pi over 3, which would be 4 pi over 3. Now, if we just had sine of x or sine of u, these would be the two solutions. But we need to find the solutions for x, right? So let's put that back into, instead of u as my two solutions, let's put x minus pi over 3 back in there. Set it to our first solution, which was negative pi over 3. I got negative pi over 3 only because we did the arc sine there, and that's the solution we would get. But we also know there's another angle in the third quadrant. So I'm going to take that x minus pi over 3, the u value, and set it equal to negative pi over 3. Or 4 pi over 3, sorry. 4 pi over 3. So we have the angle that's in the third quadrant and the angle that's in the fourth quadrant. If we add pi over 3 to both sides, we get x is equal to 0 here. Pi over 3 plus pi over 3. Oh boy. Okay. And over here we get, if we add pi over 3, we get 5 pi over 3. Just add pi over 3 to both sides. Okay, so the solution set then is this and this. And those are between 0 and 2 pi. 5 pi over 3 is in the fourth quadrant, and 0 is on the x-axis. So 0 degrees and 5 pi over 3 is the solution there. Let's see if it takes that as our solution.
Professor,
Yeah.
these solutions, is this consider the infinite set or the finite set?
They want us to do the finite set
Oh, okay, I see.
in this particular
Thank
case.
you.
Yep. If we were
Okay.
to describe the infinite set, we could go 0 plus 2 pi and this plus 2 pi. 2 pi n, where n is always usually denoted as being a integer. So a positive or negative whole number. 5 pi over 3. So 5 pi over, oops. There we go, 5 pi over 3. Right? So you kind of pretend like it's just the sine of something, sine of u. What are the solutions there? And then we need the solutions for x, not for u. And so we take u's value, which is x minus 3, set it equal to one of the angles. U's value, set it equal to the other angle. But remember, for every negative, for every positive, there's two solutions for sine and cosine. Tangent's a little bit different because tangent is plus pi rather than plus 2 pi. It's positive, tan and cotangent are positive here and here, negative here and here. That's for tan and cotan. Any other ones from the first one you guys want me to work? Okay. Let's go to the other one then. I'm going to erase, reshare. Okay. Let's exit out of here. and go to part two. This is where we did the more difficult ones, kind of like the ones we worked. Any questions from the second, part two, number 6?
Can we see question? Can we see that question 6, please?
Yep, this is number 6.
Yes, Sal. Thank you.
So this is kind of like the one we did, but we've got different numbers there. Um, so I have 4. Let me write this out. 4. Uh, 4 cosine squared x plus 2 sine x minus 2 equals 0. And so we'll do the same thing. Let's get rid of the cosine, get these to sine. So that's going to give me 4 times 1 minus sine squared x plus 2 sine x minus 2 equals 0. Notice I'm just rewriting it each time. Now we'll distribute the 4 correctly this time. Minus 4 sine squared x plus 2 sine x minus 2 equals 0. Let's combine the terms that we have. We have a positive 4 and a negative 2. So that's going to become plus 2. And then the other two don't combine because one's sine squared, the other is sine. So I have negative 4 sine squared x plus 2 sine x plus 2 equals 0. And let's get rid of the negative one. I'm going to distribute and multiply both sides by negative 1. Right? That distributes to each one of those. So basically it just changes the signs. Makes that positive 4 sine squared x minus 2 sine x minus 2 equals 0. It's just going to make it easier for us to factor. And let me not forget the x that's there. All right, so 4x squared minus 2x minus 2 equals 0. Let's see if we can factor that out. It's a little bit harder when we have the 4 out here. So to get 4, it's either 2 times 2 or 4 times 1. So I'm going to try 2 first. And then to get negative 2 here, for it to be negative, my signs inside have to be opposite signs. It's the only way we get a negative, and it's going to be 2 and 1. So let's try 2 and 1. This gives me 4x minus 2x, which is, well, 4x minus 2x would give me positive 2x, and I want minus 2x, right? This would be 4x and negative 2x. That would give me positive 2. So that tells me I need to put the 2 there and the 1 here. This would be positive 2 and negative 4, which would give me negative 2x. All right, and then we can put sine back in there. So the factored version of this would be 2 sine x plus 1 and 2 sine x minus 2. All right. So let's do both of these. I have this one I want to set equal to 0, and this one I want to set equal to 0. So 2 sine x plus 1 equals 0. And 2 sine x minus 2 equal to 0. We'll solve the first one. Subtract 1, divide by 2. That's going to give me sine x equal to negative 1/2. And if I add 2 to both sides and then divide by 2, I'm going to get sine x equal to positive 1 here. All right, so what are the x's that give me negative 1/2? If we're taking the arc sine, right? And I'm doing that each time, arc sine. This x would come out to be negative pi over 6. And taking the arc sine here, x would be equal to, where we get 1, which is pi over 2. Here they want us to do the interval, but between 0 and 2 pi. But if it was the infinite, I would go plus 2 pi n and plus 2 pi n. Pi over 2 with sine, which is the y, we get that at 90 degrees or pi over 2. And every other 2 pi added to that. But to express these two answers, they need to be between 0 and 2 pi. So I'm actually going to add a 2 pi to that, which would be 6 or 12 pi over 6 plus negative. So that would be 11 pi over 6 here. And pi over 2. That's between 0 and 2 pi, so we can use that. So my two solutions are pi over 2 and 11 pi over 12. Is that right? Over 6. 5 pi over 6. Sorry, I'm going back to our other one.
Sorry, I was confused about the 11 pi over 12.
Mm-hmm. So we have
How did you get that?
negative pi over 6, and I want to add 2 pi to that. With the denominator of 6, this would need to be 12 pi, right? 12 pi over 6 is 2 pi.
Yes.
12 pi minus 1 pi is 11 pi.
Yes.
Yeah, so notice that the way to find it is to add 2 pi to it.
Okay.
It has to be between 0 and 2 pi in this case. That's how they want the answers.
Thank you.
Yep. So we got pi over 2. And 11 pi over 6. Oops, something's wrong. What did I do there? Pi over 2, 11 pi over 6. 30 degrees gives us negative 1/2, isn't that right?
Yes.
And it was plus, did I do that right? Plus 2, let's see, that's 2 pi negative 4 pi. Put that correct. Okay, minus 2.
Did you solve the pi over 2 plus 2 pi?
Well, 2 pi over 2 is the answer on the second one because we got positive 1, isn't that right? Add 2 and then divide by 2.
No, I mean like do you have to get the common denominator for the pi over 2 plus 2 pi?
Well, that would, if I took pi, I didn't add those together. You did pi over 2.
Oh, okay.
Pi over 6. What did it say? Let's see. Type your answer and type the exact answer using as needed. Integers or fractions. Use a comma to separate the answers. 11 pi over 6. We wanted negative 1/2. That's negative pi over 6. Let's see. Let me make sure I wrote the original thing down. It was 4 cosine squared plus 2 sine x minus 2 equals 0. We got 4 added to negative 2 is positive 2, but it became negative 2. Right? That's 4 plus that plus 2. Then it became a minus 2 when I changed the sign. Said one of those was wrong. Let me see what it said again. Use the Pythagorean identity to transform the equation. Okay, we did that. That's not liking something I have there. Oh, oh, you're right. I'm missing one. Sorry, guys. I wasn't thinking here. We we got the minus pi over 6, but we forgot about the fact that there's one in the third quadrant as well. And mostly because I was running out of space. Um, so we had the first one, which is pi over 2, we got that one. But we had the sine of x equaling negative 1/2. We had negative pi over 6, but we forgot to also include the one that's in the third quadrant, which is 7 pi over 6. So I forgot to include this one, which was the second. That was an obvious mistake on my part. There were two solutions in the first because there's two places where we get negative 1/2. There's only one place where we got positive 1. Does that make sense? We can do a different one if that helps. But yeah. Any other ones from here that are different in terms of their setup? Because this one's similar to the 15-minute check. I want to make sure we get ones that uh, are different enough for you. Any other ones you want me to work through here?
Could we see question 9, please?
Question 9. There is no, no. Oh, there it is. Let's go for 9. Okay. Yeah, this is a good one. Okay, so square root of 3 sine x equals 1 plus cosine x. So again, we have a sine x and we have a cosine x. We need to be able to have one to use, either a sine or a cosine. So the best way to do this is going to be to square both sides. So one of them is a sine squared that we can substitute out, or a cosine squared that we can substitute out, right? So I'm going to square both sides of this equation. Now remember over here, when we go 1 plus cosine x squared, this is 2. We have to FOIL this. It's not just going to give you 1 squared plus cosine squared x. This is times, so we can just square both parts there. So that just gives me 3 sine squared x. All right, square root of 3 squared. So we just square this part and then we square that part. When you have two things being multiplied and you square them, this is just x squared, y squared. You square both parts. But if it's x plus or minus squared, we can't just do that. And that's the biggest mistake people make. We're actually squaring x, we're squaring the sum. So we have to go x plus y times x plus y. And we have to use FOIL. So what we need to do is to multiply this plus that. So go 1 times 1, which is 1. And then do your inners and outers. So 1 cosine x plus 1 cosine x, which would be plus 2 cosine x. And then you do cosine x times cosine x, which is cosine squared x. Everybody see how I got here? So because I would still have I would have a hard time switching from, so I need to square that or to get rid of that. I would have a hard time switching the cosine to a sine because I would still have this cosine, right? Even if I switched out this one for 1 minus sine squared, I would still have this cosine here. So the correct thing to do here would be to take out the sine squared and make it cosine. So let's do that. So then I'm going to have 3 times 1 minus cosine squared x using Pythagorean identity. And we'll distribute that. And so that's 3 minus 3 cosine squared x equaling everything we have on the other side, 1 plus 2 cosine x plus cosine squared x. Let's set this equal to 0. We're going to have to factor this. So I'm going to add 3 cosine squared x to both sides and then subtract 3. So we'll subtract 3 with the 1, add the 3 cosine squared x to the cosine squared x, where they are actually going to be able to combine. That makes this equal to 0 and leaves me with 4 cosine squared x. Remember, there's a 1 there. We have 1 cosine squared x, so that becomes 4. I'm going to put this in descending order. Cosine squared x plus 2 cosine x, and then 1 minus 3 is minus 2. And here we can factor this out. I'm going to do this up here just because it's a little easier to see. 4x squared plus 2x minus 2 equals 0. And to get 4 again, it's either going to be 2x and 2x. We can try that first. And to get negative 2, we've got to have a plus and a minus. 2 and 1. So let's try 2 here and 1 here. This would be 2x minus 4x will give me, 4x negative 4x plus 2x would give me negative 2x. So that tells me my signs are off. We just need to switch the signs. This would give me negative 2 and positive 4. That gives me 2x in the middle, my inners and outers. So we know the factoring of this is going to be putting cosine x back in there, 2 cosine x minus 1 and 2 cosine x plus 2. And then we got to do the 2 things for those. Let me make this bigger. All right. So the first one, let's take this. We'll set it equal to 0. So 2 cosine x minus 1 equals 0. And then 2 cosine x plus 2 equals 0. Adding 1, dividing by 2, this is going to give me cosine x equals positive 1/2. These are 2 separate here. And I'm going to subtract 2, divide by 2. That's going to be cosine x equals negative 1. Does everybody see how I got there? Here we subtracted 2, so that's going to make it -2 on the other side. Divide by 2, we get -1. Here we added 1, and then we divided by 2, so +1/2. So doing the arc cosine, we report positives in the first quadrant. Cosine is equal to 1 at 60 degrees, so pi over 3. But then we need to also do the other one. Let's not make the same mistake I made on the last one. Also talk about the one that would be in the fourth quadrant where cosine also is positive. That's, in fact, adding 2 pi to it. Well, no. We have to go 2 pi minus pi over 3 would be 5 pi over 3. So the fourth quadrant. 6 pi over 3 would be 2 pi. We take away 1 pi over 3. We want this one and that one. That gives us the x, the cosine. So we have this one, and then we have that one. Where does cosine x give us -1?
Pi.
Yep, at pi. Now, because we squared both sides, it's essential here. You can always plug these in to make sure they work, but here it's possible that we picked up extra solutions. So we need to make sure that these 3 solutions we found actually work. And we are doing only the ones between 0 and 2 pi. So we need to plug these into to the original equation to see if they actually work for the original equation. Is it okay if I erase some of this here? I'm just going to go ahead and erase all this over here. Give me some room. And we'll plug them into the original equation. What you may end up with that it works into this equation, but it may not work with the original equation. So we'll just got to check these one by one. So original thing is square root of 3 sine x equaling 1 plus cosine x. What you may see on a lot of these is they're equal, but negative on one side and positive on the other. And so they're not equal. All right, so let's try pi over 3. Root 3 times sine of pi over 3. And there's no way to go about doing this. You just have to do this substitution once you've squared both sides of the equation. Well, what is the sine of 60 degrees? Isn't that root 3 over 3? Yes. Root 3 over 2, sorry. Root 3 over 3. And this is times square root of 3 over 1. So this gives me, well, 3/2. Let's go to the other side. Cosine of 60 degrees is 1/2. And 1 plus 1/2, or 2 over 2, plus 1/2 is 3/2. So this one worked. So I know that this is one of my solutions. Let's try 5 pi over 3. Everybody see what I did there? Any questions? Always, you can raise your hand if you missed something there. Let's try 5 pi over 3. So I'm simply going to put 5 pi over 3. Pi over 3. which is in the fourth quadrant. 6 pi over 3 would be 2 pi. So we're in the fourth quadrant there. The sine of 5 pi over 3 is going to be negative root 3 over 2 multiplied by root 3 over 1. So this is negative 3 halves. Well, the cosine of 5 pi over 3 is still 1 half. And 1 half plus 1 is 3 halves. And so we see these are not equal. So 5 pi over 3 is not one of my solutions. Here it's negative, here it's positive, not equal to each other. Close, but that's what you see a lot of times is the same number, but one is negative and the other is positive. Let's just go ahead and do pi and see what we get. Does pi work? What is the sine of pi?
0.
0. So this would be 0 times root 3, which is 0. And cosine of pi is negative 1, and negative 1 plus 1 is 0. So pi worked. So we have pi over 3 and we have pi appear to be the two solutions that worked. Well, let's type that in there. I love how they're.
Pastor, I got a question.
Yeah.
So it'll be pi over 3 plus 2 pi n and pi plus 2 pi n.
They don't want, if you were putting the infinites, yes. But here they're just having us report in the interval.
I know, but like, are these considered infinite or finite?
So these are finite. Finite means
Just
countable,
just a
and
read. Okay.
infinite means you couldn't list them all. So if they're finite, you can list the solutions. The only way we can make them finite, because otherwise there's always an infinite number of solutions when it comes to trig functions, because it's a circle, right? So any angle
Yes.
solution, you could always go 360 more and 360 more in infinite ways, or negative 360 more. You wouldn't be able
Okay.
to. So because it says between 0 and 2 pi, they're wanting us to find the finite solutions. And
But like writing, yeah, to like writing these on a like say on a test,
on the
we
test, I'll have
put
you do both, kind of like I did on the 15-minute check. I'll have you tell me what the finite solutions are and what the infinite solutions are. So I just have you
okay,
list both of them.
okay. Thank you.
Yep. Any others from part 2? So remember, whenever you square both sides, and they kind of give you that here, but they say first square both sides. But we kind of had to do that in order to be able to swap out a cosine for a sine, right? You kind of had to do the square root. How's everybody doing out there? All right. Okay, feeling good about this. Good. I like to hear that. Yeah, it can be challenging. Like I said, rather than getting drawn into all the formulas and stuff, remember that for every, like here we have, we broke it down till it was the cosine x of 1 half. Think about the two places, the two angles where we get positive 1 half. If it was negative 1 half, there would be two places where you would get negative 1 half. Uh, when you're at the when you're getting zero, there's two places for cosine and two places for sine. But if it's positive or negative one, it's always just one of the two. It's either positive one gives you one angle, negative one gives you one angle. Um, so think about the unit circle. If you can picture that, it's not a bunch of stuff you've memorized. You're getting a visual of what you're trying to find rather than using all these formulas. It makes it a lot easier. The formulas will help you find that second angle, but you can do that, right? If you know that I know it's in I have this one, and then I know it's over here as well. These are the two places where sine is negative, for example. Um, all it's saying is add pi plus the the reference angle that would be here. If this is negative pi over 6, uh, take pi and add pi over 6, right? You want the angle that going back would give you that pi over 6. So it's 6 pi over 6, or if you're dealing with pi over 3, it's 3 pi over 3. These are all pi. If you're doing 12, it's 12 pi over 12, and you're adding another pi over 12. So you'd have 13 pi over 12, right? Wherever those are, there's another angle in there that has that positive outcome. And that's why with functions, we had to limit it because we couldn't get two solutions. If you go into your calculator, you don't want to get two solutions. You want to be able to figure out what is the solution for this problem. All right. Uh, so you'll be working on another topic over the weekend. Uh, be watching. I'll most likely be sending your tests individually to you through Canvas. Um, I apologize if I've missed any of your messages. I went through them yesterday to try to catch myself up. But please feel free to email me if you have questions. If I haven't replied, you may need to remind me. I'll be going back through them again. Thank you, and I am feeling better. I hate getting hit up in the middle of a quarter with something like this. It's not very often, but usually I can just do a Zoom thing and it's fine. It was a little more extreme in this case, but yeah, it's the season, right? And I know all of you know exactly what I'm talking about. Uh, all right. Well, have a great rest of your week and weekend. We'll see you guys fresh and ready for our one class meeting next week. We do not meet on Wednesday because it's Thanksgiving Eve, but we'll be meeting Monday. Coming up to the end, so don't miss. Show up, stay strong to the end, and I'll see you guys on Monday. I'll be sticking around if you have questions too. Thanks, you guys. Appreciate it. Mary, you're taking your test tomorrow. Is that right? Okay, great. Sage, Savannah, do you guys have questions for me? I believe it's not this Monday, but the following Monday. It's either the following Monday or we'll just see how it goes. It'll be either Monday or Wednesday. You're welcome.